downwards is positive. Can you see? You need to be able to tell that this one tells you that downward is positive. How do we know that? Because when the ball first drops, it goes downwards, and because it increases its velocity, you can see that it's in the positive side of the graph. Okay? Then when it hits the ground, boom, there is a sudden change in velocity, all right? And immediately it passes into the negative zone, right? Okay, and at this point here, what is going on? It is bouncing, and it bounced off and is moving back up to a height that leads to a 0. Is everyone clear about this? All right, so you have to know that anything to do with vectors, you must look out for what they define as positive direction. Okay? All right, now the variation of time and velocity of the ball is shown. Express the net force exerted on the ball using the relevant values given. Now, I discussed with Mr. Lim. This one apparently is not a very good sentence. All right. What is the net force? You have to know intuitively. The question is, when the ball is falling, do we consider any forces acting on the ball as it is falling? There is, right, actually. Because gravitational pull pulls the ball. There's nothing preventing the ball from falling, right? It keeps falling down, right? So there's the net downward force. That's why it's accelerating. But what this question is actually asking is, what is the net force exerted on the ball when the ball is hitting the ground? So actually, all we are concerned with is this zone or this area over here.
But how do you know it's when the ball is
Yeah, so this question is faulty. The problem is with the question. Okay? All right, so with this, let's focus on the definition of force. So we learned earlier on that force is the momentum, change in momentum over time. So we can just write it down. Force equals to the change in the momentum over the time. Sorry, not m, this is mass. Change in p over time. Okay. In this case, we can tell that the change in momentum is, there are two forms to this. One form is, okay, m and v over t, right? Yeah. Correct? So you could have a change in mass or a change in velocity, but because the object is always the same mass, so actually it is constant m, but there is a change in velocity. So where does the change in velocity come from? If you look at the graph there, you can see this is the initial and this is the final. This here is the VI and this here is the V final. Alright, so with this we can plug it into the formula. We have m, okay, and then we ask ourselves, what is the final velocity? This one, right? And isn't it in the negative? So we can say it is minus VF, correct? Minus VF, and then it's always, the change means the final velocity minus the initial velocity. So minus initial velocity, and then the time in which it takes place. In this case, we can find the time by taking t2 minus away t1. t2 minus t1. Okay? Alright, okay? So you can also express it in a negative m Vf minus Vi over T2 T1. Alright, this is just another representation.